Welcome to the Explainer. Today, we are diving headfirst into literally one of the most thrilling speculative science questions of all time. We're looking at paleontology records and some seriously mind-bending thought experiments to explore a timeline that, well, never actually happened. So let's just get right into it.
Picture this, 66 million years ago. A city-sized asteroid hurtles toward Earth, strikes the shallow sea of the Yucatán Peninsula, and boom, sets off a devastating chain of events, wiping out about 75% of all species. It brought the entire 180 million year age of reptiles to a sudden catastrophic end. But imagine if that 10-kilometer space rock had just sailed right past Earth. Or what if it arrived just a few minutes later and splashed completely harmlessly into the deep ocean? What exactly would our world look like today? To figure out who would be running things today, we first have to look at the massive biological advantage that made dinosaurs so incredibly successful for over 150 million years. I mean, just look at the sheer scale of a brachiosaurus compared to our largest land mammals like mammoths and elephants. They reached these unprecedented, massive sizes because of a very specific biological strategy. Which brings us to food webs, survival, and the reality of extinction. We really need to separate the Hollywood pop culture from actual paleontology to understand how these animals truly reproduced and ate. You see, there's a stark contrast in survival strategies here. Dinosaurs were the ultimate R strategists. Now, that just means they produced a massive amount of offspring that grow rapidly. A single sauropod could lay anywhere from 500 to 4,000 eggs over a 40-year lifespan. That is absolutely wild when you contrast it with large mammals, which are K strategists. Mammals have long gestation periods, we nurse our young, and we breed slowly. Because dinosaurs could just drop huge clutches of eggs and move on, they didn't carry the same energetic burden. That's exactly what allowed the adults to grow to those colossal sizes. But there was a biological catch to the strategy. Because they laid hard, calcified eggs, there was a physical limit on how big an egg could actually get. So even the most colossal, city-block-sized megadinosaurs began their lives as tiny hatchlings, literally no bigger than a chicken. And they were ready to leave the nest immediately. This incredible reproductive engine meant dinosaur populations could recover extremely fast from localized disasters. They'd just flood the ecosystem with fast-growing juveniles. Okay, but right before the asteroid hit, the food web was actually shifting. If we look at reconstructions of North American food webs, there's a measurable drop in ecosystem connectivity right at the final stage of the dinosaurs. The impact of the giant bulk-feeding mega-herbivores was declining, and they were being replaced by medium-sized dinosaurs. So the overall food web was becoming slightly less interconnected. And while those giant dinosaur populations were still firmly established in their niches, something completely fascinating was happening right beneath their feet. Smaller vertebrates, including early mammals, squamates, and birds, were rapidly increasing their impact and expanding their ecological niches. Mammals weren't just waiting around for the asteroid to hit, they were already diversifying and structuring the food web right in the shadows of the big guys. So, moving on to the alternative evolution timeline, basically entering the spec zoo, or speculative zoology. Think about it. If the asteroid misses and the food web doesn't collapse from that sudden shock, how do these creatures evolve over the next 66 million years? Well, geologist Dougal Dixon explored this in his wildly popular 1988 book, The New Dinosaurs. He suggested dinosaurs would have continued to dominate global ecosystems with some truly bizarre new forms. Without the extinction event, he hypothesized creatures like the cutlass tooth, which would basically take over the pack-hunting niche of mammals, or the gourmand, a massive T-Rex descendant that completely lost its arms and developed a distensible jaw to swallow prey whole, kind of like a snake. It is a crazy, fascinating look at how dinosaur forms could have stretched to fill literally every available ecological niche. But then we have the dinosauroid thought experiment, which stems from Dale Russell's 1982 hypothesis. This is probably the most famous and definitely the most highly debated speculative concept, and it involves a very specific, small, bird-like theropod called Stenonychosaurus. Back in 1982, Dale Russell, who was a curator of vertebrate fossils at the Canadian Museum of Nature, proposed a really provocative idea. He noticed this steady evolutionary trend toward larger brain sizes over time. Russell suggested that if this brain growth trend had just kept going for another 66 million years, the descendants of Stenonychosaurus might have evolved an 1,100 cubic centimeter brain case. To put that into perspective, that is a brain volume rivaling our very own. The crucial metric you need to know here is the encephalization quotient, or EQ. Stenogysaurus had an EQ about 6 times higher than other dinosaurs of its era. At roughly the size of a German shepherd, it possessed binocular vision and semi-manipulative fingers. For Russell, these were exactly the perfect evolutionary building blocks for higher intelligence.
And this whole line of thinking led to the design of the Dinosauroid. Russell hypothesized this bipedal, totally humanoid creature with 3-fingered hands, large eyes, and a toothless beak. To support the massive energetic demands of that big brain, he even speculated it would evolve to have a navel and give live birth via a placenta. Oh, and it would speak in a language that sounded like complex birdsong. It's an incredibly striking image that just completely captured the public's imagination.
But let's talk about the limits of dinosaur intelligence for a second. It is time for a reality check. As captivating as the Dinosauroid is, we really need to bring this thrilling thought experiment back down to hard biological reality. How do modern paleontologists view this hypothesis today?
Well, the pushback has been pretty intense. Modern paleontologists heavily criticize the Dinosauroid as being suspiciously human. It relies a bit too much on anthropomorphic evolution, which is basically the biased assumption, but the ultimate pinnacle of intelligence absolutely must look like us. In reality, a highly intelligent theropod would almost certainly retain a horizontal posture, keep its long tail for balance, and manipulate objects using its beak and feet, much like modern intelligent birds do right now.
As paleontologist Darren Naish brilliantly points out here, the humanoid body plan is likely just an evolutionary fluke of our specific primate lineage, not some guaranteed inevitability of intelligence. Think about crows and ravens. They are technically modern dinosaurs. They can craft hooks, solve really complex water displacement puzzles, and even play, all without needing an upright, tailless humanoid body. Furthermore, there is the question of the brain itself. Some recent studies actually suggest a T-Rex might have had the same number of neurons as a baboon, which sounds terrifying, right? But Dr. Anton Reiner notes a really crucial caveat here. Having a high number of neurons doesn't automatically grant human-level intelligence. The architecture of the forebrain matters just as much as the raw neural density. Which brings us to arguably the most vital piece of the puzzle, us. If dinosaurs didn't go extinct, would humans ever have evolved to walk alongside them? The ecological evidence paints a picture of dinosaurs occupying highly stable, firmly entrenched niches. Because of their fast breeding, R-strategy reproduction we talked about earlier, they dominated the megafauna space so completely that they likely would have continued to suppress mammalian evolution indefinitely. Dr. Stephen Brusade summarizes it perfectly. If it weren't for that abrupt, devastating shutdown of the trophic network, literally the sudden removal of the top-heavy dinosaur ecosystem by the asteroid, the tiny, scurrying mammals of the time would never have had the ecological breathing room to expand. Primates would likely have never climbed out of the trees, onto the savanna, and eventually evolved into hominids.
So what does this all mean? The final, staggering takeaway from this explainer is a question of our very existence. The dinosaurs weren't failing. They were a highly successful, stable biological dynasty. It quite literally took a massive rock falling from the sky to dethrone them, which leaves us to wonder, are human beings and all our incredible civilizations simply the lucky beneficiaries of an asteroid that didn't miss? It's a hugely humbling thought to leave you with today. Thanks for joining me on this explainer, and keep questioning the world around you.